No, a ground fault interrupter circuit should not be installed in a conduit with non-ground fault interrupter circuits. This is primarily due to the potential for nuisance tripping and the compromise of the ground fault interrupter's intended function. Firstly, consider the fundamental principle of ground fault interrupter operation. A ground fault interrupter constantly monitors the current balance between the hot and neutral conductors. Ideally, the current flowing through the hot wire should equal the current returning through the neutral wire. When a ground fault occurs, meaning current leaks to ground through an unintended path, this balance is disrupted. The ground fault interrupter detects this imbalance, typically a current leakage of 5 mA or more, and quickly trips the circuit to prevent electrical shock. Secondly, the presence of other circuits in the same conduit can introduce capacitive coupling between the conductors. Capacitive coupling is a phenomenon where electrical energy is transferred between conductors due to the proximity and the insulating material between them. This coupling can cause a small amount of current to leak from the non-ground fault interrupter circuits into the ground fault interrupter circuit's neutral conductor. This leakage current, even if it's below the ground fault interrupter's tripping threshold, can accumulate over time or with multiple circuits in the same conduit. Thirdly, inductive coupling can also occur, especially if the conductors are run in close proximity over a long distance. Inductive coupling arises from the magnetic fields generated by alternating current flowing through the conductors. These magnetic fields can induce currents in nearby conductors, again potentially affecting the ground fault interrupter circuit's neutral conductor. The combined effect of capacitive and inductive coupling can lead to a situation where the ground fault interrupter perceives a false ground fault. This results in nuisance tripping, where the ground fault interrupter trips even though there is no actual ground fault present. Fourthly, National Electrical Code, specifically Article 300.3 C1, addresses the need to run all circuit conductors within the same raceway or cable. This requirement is primarily to minimize impedance and ensure proper operation of overcurrent protection devices. However, while it mandates that all conductors of a circuit are together, it doesn't explicitly prohibit mixing ground fault interrupter and non-ground fault interrupter circuits in the same conduit. The concern arises from the potential for induced currents and the resulting nuisance tripping. Fifthly, practical considerations further support the separation of ground fault interrupter and non-ground fault interrupter circuits. When troubleshooting electrical problems, it becomes more difficult to isolate the source of a ground fault or nuisance tripping if multiple circuits are sharing the same conduit. Each circuit should have its own dedicated path to facilitate easier identification and resolution of issues. Sixthly, in installations where it is absolutely necessary to run ground fault interrupter and non-ground fault interrupter circuits in close proximity, shielded cable can be used to minimize capacitive and inductive coupling. Shielded cable has a conductive layer that surrounds the conductors and is connected to ground. This shield acts as a barrier, preventing electromagnetic interference from affecting the enclosed conductors. However, even with shielded cable, it's still best practice to avoid mixing ground fault interrupter and non-ground fault interrupter circuits in the same conduit whenever possible. Seventhly, alternative wiring methods can be employed to maintain circuit separation. For example, instead of using a single conduit, multiple conduits can be installed to house separate circuits. Cable trays can also be used to support and route cables while maintaining physical separation between circuits. Eighthly, consider the implications for electrical safety. While nuisance stripping is an inconvenience, it can also mask a real ground fault. If a ground fault interrupter is constantly tripping due to induced currents, there is a risk that the user will become desensitized to the tripping and may even bypass the ground fault interrupter protection altogether. This can create a hazardous situation where a ground fault goes undetected, increasing the risk of electrical shock. Ninthly, it is important to understand the specific requirements of the local electrical code. While the National Electrical Code provides a general framework, local jurisdictions may have additional requirements or amendments that must be followed. Always consult with a qualified electrician or electrical inspector to ensure that your wiring installation complies with all applicable codes and regulations. Tenthly, when installing ground fault interrupters, ensure that they are properly sized and rated for the intended application. Ground fault interrupters are available in different trip current ratings, such as 5 mA, 30 mA, and 100 mA. The appropriate rating depends on the type of equipment being protected and the potential hazards involved. For example, 5 mA ground fault interrupters are typically used for personnel protection, while 30 mA ground fault interrupters are used for equipment protection. 11th, regularly test ground fault interrupters to ensure that they are functioning properly. Ground fault interrupters have a test button that simulates a ground fault and should cause the device to trip. It is recommended to test ground fault interrupters monthly to verify their functionality. 12th, proper grounding is essential for the effective operation of ground fault interrupters. The grounding system provides a low impedance path for fault current to flow back to the source, allowing the ground fault interrupter to detect the imbalance and trip the circuit. Ensure that all electrical equipment and wiring are properly grounded in accordance with the National Electrical Code. 13th, consider the impact on other sensitive electronic equipment. Induced currents in the ground fault interrupter circuit can potentially affect the performance of nearby electronic devices such as computers, audio equipment, and medical devices. In critical applications, it may be necessary to use shielded cable or other mitigation techniques to minimize electromagnetic interference. 14th, when designing electrical systems, plan for future expansion and flexibility. Avoid overcrowding conduits with multiple circuits, as this can make it difficult to add or modify wiring in the future. Provide adequate space for future circuits and consider using larger conduit sizes to accommodate potential expansion. 15th, it is important to use appropriate wiring methods for the specific environment. In wet or damp locations, use waterproof or weather-resistant wiring and fittings. In corrosive environments, use corrosion-resistant materials. In hazardous locations, use explosion-proof wiring and equipment. 16th, proper labeling and identification of circuits is crucial for safety and troubleshooting. Clearly label all circuit breakers and wiring to indicate the circuits they control. This will help to prevent accidental disconnection or energization of circuits during maintenance or repairs. 17th, ground fault interrupters are designed to protect against ground faults. They do not protect against overloads or short circuits. However, current protection devices, such as circuit breakers and fuses, are required to protect against these types of faults. Ensure that all circuits are properly protected by both ground fault interrupters and overcurrent protection devices. 18th, when working with electrical wiring, always follow safe work practices. To energize the circuit before working on it, use appropriate personal protective equipment and follow lockout/tagout procedures to prevent accidental energization. 19th, if you are not comfortable working with electrical wiring, hire a qualified electrician to perform the work. Electrical work can be dangerous and should only be performed by trained professionals. 20th, in summary, while the National Electrical Code doesn't explicitly prohibit mixing ground fault interrupter and non-ground fault interrupter circuits in the same conduit, it is generally not recommended due to the potential for nuisance tripping and the compromise of the ground fault interrupter's intended function. Best practice is to keep them separate.